Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Spring constant is given by the equation a half kx squared, and this is equal to the electrostatic potential. Now we can rewrite this value x as the change in the radius, delta r, and that's the same as saying r minus r naught. When we look at the diagram given in figure 2917, we see that the simple harmonic oscillator curve crosses the axis when potential energy equals 0 at some point r. Now we have to estimate this point. So I've taken an estimate at r equals 0.125 nanometers. Okay. And we know that as the curve changes on the x-axis, so as we go from r0 to r, there's a change in the potential by about 4.5 electron volts. Okay, so now we have everything we need to calculate this value k. So we know that the potential is 4.5 electron volts, and this is equal to 1/2 k r minus r naught. So we can do 0.125 minus 0.074 nanometers. Okay, so we can say that k is equal to 2 lots of 4.5 UV over 0.051 nanometers. Now we need to be careful about units, so we need to convert electron volts to joules. I mean, we would like to write nanometers in terms of meters. So this becomes 9 times 1.6 times 10 to the minus 19 EV times joules per EV, because there are 1.6 times 10 to the minus 19 joules per electron volt. And then we get 0.051 times 10 to the minus 9 meters. That's the same as 0.051 nanometers. And once we compute this, we get roughly 554 newtons per meter. Now, you may find a discrepancy due to your reading of the curve. You may decide it be 0.12 or 0.13. This range is okay, but just remember that any small change you make will result in a big change in the answer at the end. So if you get the spring constant to be over 1,000, that's okay, as long as you've taken a reasonable estimate for the value of R here. Part B asks us about a classical simple harmonic oscillator. So then we use equations of motion. So equations for frequency. So any simple harmonic oscillator has an angular frequency, omega equals 2 pi f. And the angular frequency is also equal to root k over m. And then we also know that for any wave, lambda equals c over f. And we can substitute this in so that we get lambda is equal to 2 pi c root m over k, where we've taken the frequency here, rearranged for lambda, subbed it into the angular frequency, and then rearranged to get the wavelength on its own. And then once we substitute in all our values, we should get roughly 2 pi multiplied by 3.0 times 10 to the 8. And then we know the mass as 1/2 of 1 atomic mass unit. And we can just divide by the value that we got before. Okay. Now, I managed to get an answer of 2.31 times 10 to the minus 6 meters. But as long as your answer is around 2 times 10 to the 6 or 2 micrometers, you should be okay.